this lesson is going to show us how to hand draw in field lines for a system of charged particles in the region of space around those charged particles. So here we can see we have a charge of +2. It could be +2 coulombs, +2 nanocoulombs. It's not really important that the actual value of coulombs that it is. And we are also given a charge of -4. And again, they could be coulombs, nanocoulombs. The field would not change. The field map profile would not change just based on the prefix of the charge. Now, as it says here, our scale is really important. Do not start to draw field lines until you've determined your scale. And the scale is the number of lines for the smallest q. Well, our smallest q is +2. And if you count, you can see we have 8 field lines there. 2, 3, 4, 5, 6, 7, 8. So we have scale, and I'll put it in up here because we need the space below to actually draw our lines. We have 8 lines per 2 units of charge. Okay. So that means for my -4, we're going to have 16 lines drawn in. So in terms of the procedure for drawing the field lines when you're given a system of particles to determine the field map for, you first want to put in positive test charges. So you have all these positive test charges drawn in close to the individual point charges. So I'm putting them in really close, and then I'm using that the +2 is going to push that test charge. That's where I get my 8 arrows. Notice my arrows are all in quadrants, not on axes. So divide up the total number that you're using, use an even number, and put them in the quadrants, not on axes. So then when I go to 16 over here, I put 4 kind of equally spaced in the quadrants. I use my positive test charges, and notice my field lines are pointing now into the -4, and this is consistent with starting on positive and ending on negative. Now we have to fill in the rest of the space around these source charges. Well, how do we do that? What you want to do is look at symmetry in the problem. And by symmetry for this problem, I notice that the top half of the page and the bottom half of the page should be a symmetric profile. It should be a mirror image, because there's no reason to expect nature to prefer the top to the bottom to change the profile for our electric fields. We have symmetry in that along the x-axis, but not in the left to right, right? Because we have a -4 on the right and a +2 on the left. Well, what you want to do, my recommendation is to use a pencil and have a little bit of an eraser there. Go to your lowest, start at your lowest charge, in this case the +2. Take your pencil and just go doot, doot. Oops, let me get a black here. Pencil. And go doot, 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 and connect it to the corresponding line on this side. So why did I draw it like that arc? Well, I'm not going to constantly draw in test charges, but think about how a test charge would behave along that dashed line. And you just keep going. And what you'll see is you'll get, as you go along and you get more experience, you'll be able to do this a lot more quickly. Doot. There we go. Doot, 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 doot. Here's a little tricky because we're going to go all the way around here, and you just keep going. So let me give you a chance to try that, connect them up, and pause if you want, and when you unpause, we'll show you what all those dashed lines look like. Okay, hopefully you've unpaused, and here we go. There are all your dashed lines. Notice they all kind of go over, and look at the dashed lines over here for the -4. Normally, this dashed line would continue following this profile and go over and connect, but we do not connect it because our scale shows only 4 lines coming out of the 2, or I'm sorry, 8 lines coming out of the 2 and 16 out of the 4. So it's okay to let these dangle in space. All right? And then, of course, we have symmetry on the bottom, right? We have the mirror image down here. so that when we look at the complete profile, ta-da! Ah, look, you get this kind of cool image. Notice I added arrows after I really drew it in, took my time and drew it in nicely. I used my pencil, my eraser to try and make it as symmetric as possible. And I drew in some extra arrows in here, beginning on positive, ending on negative. Anywhere where these lines are closely spaced together would be strong field. Anywhere where they're more widely spaced would be weaker fields. Positive test charge, any proton that I put in would follow that line of force, that field line, and that's the way it would move. An electron, if that were placed in, would obviously then be accelerated backwards against it. So you will get much better at doing these as we go along, and you'll be able to do them relatively quickly. You see that there's kind of a symmetry and an aesthetic value to them that you're going to get used to. And I think we'll have some fun doing them and practicing them in class as well. So the last part of this lesson is for you to take a positive 2 and a positive 2. So here we had a positive and a negative, so you have to think a little bit about how this one is going to look. I gave you the scale of 8, and I already put them in the quadrants for you, so you have them already in the quadrants. So see if you can follow the same procedure that we just talked about. Pause the video here, and when you unpause, I will show you the solution. Okay, hopefully you have tried it out, and let's see. Does yours look like this? All right, I put my positive test charges in. The positives push and push. And here, it's a little tricky because we had to see that right here at the middle, right here, we would have actually an electric field equals 0 point right at the center, right? Because this positive 2 would push a test charge here to the left. This positive 2 would push the test charge to the right. So we do get 1 point right in the middle that would be 0. So, as I said, there's a nice aesthetic value to it. If you got it, that's fine. If you didn't, we are definitely going to practice. So, and most often, people kind of have fun getting used to drawing them and seeing the different patterns. So, we will move on.